Welcome to the another session in Frontiers in CFD. So today we will see the CFD analysis of fluid flow in a Tesla wall. So the today's objective is to prepare the geometry of Tesla wall using ANSYS design modeler. Preferably we'll be using the sketching tool to prepare the geometry. Second objective is to generate high quality computational mesh and apply the name selection on computational domain in order to apply the boundary conditions in the setup part. So next objective is to apply the boundary conditions and visualize the fluid flow. So this is one of the reference the geometry which we are the diagram which we are following for preparation of geometry. Alongside that we have an image which is on the right hand side. So this is what we are going to follow. Preferably when the fluid flows are taking place through such kind of Tesla wall, maybe it can be used for further cooling of lithium and batteries or some other cases. So this is we're not going to prepare the entire model, but we are going to prepare with one or two you can say Tesla walls, and accordingly we'll visualize how the fluid flow is likely to take place. So welcome you all. Today we will see the fluid flow simulation in the Tesla wall. So this is one of the example which is been available. We'll follow this dimension which is available, and accordingly we'll proceed for preparation of geometry, and then we'll try to do the simulation on the same. So first of all we'll start with the workbench window. Here what we are probably going to do is we are preparing the sketch of this particular wall which is been present over here, and with the help of these dimensions, once the dimensions have been done, we'll try to we can see do the simulation for the same, and we'll check out how the things will appear for the simulation. So the dimension table is also been available. So this is one of the table which we are observing. Now accordingly we'll proceed for this particular case. So let's open the workbench window. Yeah, so workbench has been open. So click on fluid flow fluent, go to the geometry, select the new design modeler geometry. So first of all set the units to millimeter, click on any one of the plane. So depending on how you want to draw, whether you required in vertical direction or horizontal direction, accordingly you have to select the plane. So I will preferably go with the ZX plane, and accordingly I will proceed for it. So if you see, this is how the ZX plane will look like. For the sketching, I will start with the we can say the arrangement which is in the form of the sketch for the wall as per the dimension which is provided, and accordingly we will prepare the wall. So first of all I will draw a line here. Okay, so any line has been drawn here, as you can see. So the dimensions of the line I will take as per the paper which is we have specified. So this is L1 and L2. So okay, so this is L1 and L2. So these are the dimensions which we are going to follow. So L1 you will say 10, L2 is 2, so total distance is equal to 12. So I will take this distance dimension, this is equal to 12. So let's take this one is equal to 12. Okay, now I will take the dimensions of this point with respect to this line. So this one I required as per the paper. So from this end to this end, that is L6, we will have 50. So I will take this is equal to 50. Okay, so this is done. Now I have reached to this point as per the paper. So we have reached to this location. Then this is one straight line which is available. So you may actually draw a straight line up to this, and then accordingly also you can proceed. So what I can have is, if you see the dimensions which are available, so from this point to this point is L5, so I will go with L5, that is 24.65. So let's draw a line from this to here. So this is your dimension, that is equal to 24.65. So I will put it 24.65. So this is my dimension, and rest of the thing here, it will be a line which is coming from this to this end. Okay, so let's check the dimensions are up to this location, and after that we have to draw a curve. So the thing is, now you will see this is a curve of radius. Here r is mentioned, that is equal to 22. So the first curve which we will draw, again it will be of radius 22 from the. So how to draw this? So I will go with the draw option. There are many options available. So arc by tangent, arc by center. So these are the two options which are available. uh, Arc by 3 point is also one of the option available, but I will preferably try to go with the arc by center here, and select this 2 as a point. Okay, just a minute. Back. So let's take arc by 3 point, not by center. So arc by 3 point I will take. So this is any arc I have drawn. Let's take the dimension here. So R4, now it is mentioning 23. So I need this to be equal to 22. So enter that value. So what you will have, this will you will get as a center of the object. Okay, next is there will be a line which is coming from here to here. Okay, so this is a one line. Now there is an angle between these two lines. So again we can we have to draw that angle. So let us say this is A. So the dimensions, the radius is 2.5, angle is 33. So this is what we have. Now I will take the radius that is equal to 2.5 as per the dimension which is been available. So how to draw this? So we'll go with the option that is arc by tangent. So select this line, select this line. Okay, I will specify the radius here. So that is equal to 2.5. So mention that value. So this is the arc which is obtained here. Some of the things will be unnecessary, that you have to trim it out from the object. So one more time, let's go back to the object and see. Okay, so I have drawn this part now. So width of this is W, you can see it is 2. So I can just draw one more line which is going up from this. So here, so I need this dimension to be equal to 2. So mention this is equal to 2. Okay, next is if you see here, so L1 plus L2 you know, and this is the location is L3, and the center is here, that is L4. Okay, so first of all what I will do, I will draw up to L3. So that is L1 plus L2 plus L3. So, and if you go to the center, this will be the L1 plus L2 plus L3 plus L4. So this is the total dimension which we are being having. So if I take the whole dimension, that is L1 plus L2 plus L3 plus L4, so that is will become, say L1 is 10 plus 2 plus 8.75 plus 7.85. So L1 plus L2 plus L3 plus L4, so that goes 28.6. So the center here is 28.6. So you can actually reach to the center of that as a 28.6, but preferably what we can do is we'll draw the second curve, and with the help of the second curve then again we'll try to do the same thing. So we know the center for this. So I will try to draw one more circle here from the same center, and the dimensions for this will be equal to again. So this is as for the diagram, this is radius is 22. So this is 2. So the next radius will be equal to 20. So I will take this diameter coming. So I will take diameter as a 40. So this is your point of intersection. Okay, so this is what we have as a point of intersection. Now this circle is drawn. I will just try to draw any sketch from here. So one more time, draw a line from this point. Let's go horizontal. So what should be the dimensions of this? So either you can first reach to point L3, let us say L1 plus L2 plus L3, or directly you can go to the L4 point also. So that will be your center. So let's take the dimensions here. So V8 will put the value that is coming out to be 28.6. So this will come to the other end that is related to your circle. So again you will see a kind of curve here at this particular portion. So assuming this line and this one will again we can say have the dimension as per we are having this kind of curve. So this line and the circle will intersect at some point. So we'll just try to draw one more line which is going up from here. Let us say dimensions that is equal to 2. Okay, now one more line I will draw which is coming from here to here. So this is the point of intersection we are having uh, just with respect to the outer circle, but we required a circle which is passing through this one which is having a radius that is equal to, sorry, diameter, sorry, b is your radius. So radius is 4, so that is what we required at this location. So as per the dimension we have reached to this point location B. I need to draw this circle. So for this I will go with some, I will explore the options by which I can do this. If I go with arc by center, this one and this, I can complete a circle here. Similarly I will go with the this one. So this is plus 2, so B is your 4, so this will add to the, so again same location I will go here and I will took this one. Okay, so I have drawn this part. Now just like we have drawn this curve here, same curve will be drawn here. So for this I will select arc by tangent. So if you see this is radius is 2.5, so 2.5 plus 2, it will be 4.5. So I select this one and this one. So dimensions of this I will select 4.5, make it 4.5. So accordingly now this is completed. So in addition to this, if you go with this option, there is a C over here, so that is radius 2, so that we have to follow. So for this again we'll select arc by tangent. So this is one of the line. Okay, so we have to ensure which line will touch which. So here, so this arc will be of 2 as per the diagram and draw this one will, sorry, not this one. So this one will overlap here. So I will select this is to be equal to, okay, so R13 it shows uh, R12 is okay, not this one. Or I will do is, sorry, so from the same center I will draw a circle. I got the center now. So from the center I will take here. So just check it out, the intersection here. So this is removed. Yeah. So you can have this is the real portion of the object. So let's remove the unnecessary things which are not required as per the diagram. So this is the complete section which we required. So here this is not required. This is not required. This is also not required. This is not required. Okay, so this one will be eliminated. This will also be eliminated. Carefully you have to do this thing because there are many parts here. So you should not remove. Okay, this is slight error here. So we'll make it correction. So this is not the correct. So I will go with the one more draw option. Arc by tangent. Select this. Select this. Okay, not coming. Specify dimensions. That is yeah. Now it is related. So you can see now this is completed. Check out for unnecessary things if any present. So here also you have to check it carefully if something is unnecessary or not. Okay, so uh, this one is not required. This is not required. Then this is not required. This is to be removed. This is to be removed. This is to be removed. So this is there. This is there. This is removed. Yeah. So carefully you have to look it for everything. Whichever the necessary things are there, they should be there as it is. Whichever are unnecessary, that has to be removed. Just check it for if anything is pending. Okay, so for checking it, you may go back to the sketch and accordingly we'll see is there any portion which is left or not. So this is how the sketch is actually been modified. Let's do one more thing. Now create a primitive, that is a box. So what should be the dimensions of the box? So you know the all the remaining dimension, that is 50 by so 50 is one of the dimension. So what I will do, this, the second dimension I will take it around 3 because the 2 is probably will take is the depth and the other component will take maybe around 22. So first of all this direction x I will take 50, that is not as it is, will take it 50. Okay, X will take it as 50, Y component here, so we'll take it around say 3, and Z component will take it around, let us say 22. So let's check it. Okay, so it is coming on this side, so preferably we will require this on the other side. So Y component, sorry, Z component, I will take it, let us say minus 11, where it goes, just check it. Okay, so this will be somewhere at the center. I will take this on the other side. So Y component I put 3, I will put it minus 3, so it will be on the other side here like this. Now, so this looks to be quite at the center, so if you want you can keep it, or you can modify it further maybe at the later stages. So the sketch is actually been prepared and the box is also been there. So as per requirement you may reduce the size of the box. So let us say Z component we took 22, we may take it maybe, let us say 15, and let us say minus 7.5 here. Let's check how much it goes. Yeah, so here it is slightly touching, so you may take it maybe let us say minus 7. If I just check it, it will go out. So let us take it minus 9, maybe slightly more. So if you have done the sketch properly, the extrude operation will be executed properly. If it is not there, then you will see some errors which are coming. So direction vector I will select. So I don't want this direction, I want the reverse of this. So direction vector I will go back again. So this is not the required direction, I will take the reverse one here. So I want only 2 mm as a thickness, so put it here. Make it apply and let's make it generate. Okay, so it has been generated easily. So if you are finding it error, then probably it may not come out. So if you have done some wrong with the sketch, then it will not come out. So we have done this as per the dimension, which we have followed here. So slightly on the complicated side, but you can do it here. So the way it has been done. So this is the solid part and this is your solid part, but you will mention this as a fluid part now. So this is fluid is on. So this is your first one solid and this is your fluid. So this, as per the diagram which we are observing, there cannot be a single one, there can be many which is present in the actual we can say arrangement, which may be used for pulsating heat pipe or which may be used for some other applications. So this may not be the single arrangement, it can be the multiple arrangement which is kept like this. So this is one of the paper for the pulsating heat pipe, but the Tesla walls are also used for the cooling of lithium and batteries also. So this is one of the sketch which we can go for. So what I will do, I will create one option which is called as pattern. So I will select all the geometries, let us say select all, make it apply and say the direction. So let's specify the direction here. Okay, so let's make it apply. um, let's put let us say if I take it 50, what will happen, it will come on this side, but I don't want the exactly like this. If you see the Tesla models which is used for lithium and battery cooling, I'll just Google it, Tesla wall for cooling. So if you take out some arrangement like this, say for example, so this is a reverse arrangement, so whatever you are observing here, so exactly reverse it has been present on this side. So accordingly you can actually prepare the same geometry like here, but slightly modifications will also be required. Okay, so let us say we have generated this as a pattern. Now I need to Let us say go with the one option which is called as body transformation. I will make it rotate. So I will select all these two bodies, make it apply, and let's select the axis. Now how I want to rotate, so accordingly we will select axis. If you are finding it difficult, just select any one of them, and let's take a look of it. Say if I selected this one and I put it 90, so it will come here. So this is not the required direction which we are having. If I put it, let us say 180, so it will come like this. But this is as per the requirement, but we want it at this location, so you can actually shift it further. So let's make it okay. So we have generated it here. So let's go back to pattern one more time. Now what I will do, I will do some slight modifications here. So in pattern, instead of 50, let us say I put it 10. Let's check it where it goes. So we are reaching near. So let us say if I put it maybe around 5. Okay, so like this. So I shifted. Now I'll put it -100. Let's take. So this is on this side. So what I will do, this is not linear as of now. So we'll do one more operation, which is body transformation. So there is one translate option is there, or we can have the move option available. So let's see one of which one is suitable. So I select this one. So direction here, this is not the required direction. Yeah, this is the required direction. So by what I will do, I will just move it by 2, and let's generate. So now these are on the same line. Okay, so you can see they are on the same line now. But what I will do is I will have to do some operations which make them as uniform. So first of all, what I will do, I will unite these two bodies, and then we'll do the operation, or you can do the slice operation also. So for doing the slice operation, I will select the XY plane. Okay, it is there. I will make it transform Z. Okay, so let's take the value which is maybe around 5. No, I will take it 6 around. So click on generate, then go to the slice. So you see this has been separated out. Similarly, one more plane will create. So I will say offset Z. I'll select it -6 now. No, minus, I will put it -12. No, -15. Okay, so put it -14. Let us make it generate. Then click on slice, make it apply and generate. So now I will remove the unnecessary bodies which are not required. So delete. This is not required. This is not required. So click it apply and then generate. So these are the two things which is not required for us. So we have removed this. Even if you want to reduce the distance between them, so that can also be reduced. You may see some distances between the two walls, so that can also be removed, or you can actually shift this on this side also. So it depends on what kind of thing which you are doing. So you may either select this, let us say create body transformation, let us say again, you can click on the move option. Sorry, I will not go with the move. Instead of that, create. So if I select this body, make it apply, and you may select the direction. Let us say okay. So let's make it maybe if you want to reduce this, let us take it 4 and make it generate like this. So you can actually reduce the distance maybe. So if you take it 8, so the distance between them can be reduced than it what it was earlier. So let us make it 10 also and just check it. Yeah, so in this way you can bring them together. Now what I will do is I will do one operation which is called as boolean, where okay, so I will just add 3 this layers. So make it unite, generate. So this is how it has been there. Then this is and this one. So one more time I will just go on to create, do the boolean, make it apply and generate. So now this is your fluid region and this is your solid region which is available. uh, if you want some this section or as a bottom section through which the on which this Tesla wall has been there, you can actually keep it, or otherwise for fluid flow simulation you can remove that part also. Okay, so next step what I will do here, this is your solid, this is your fluid. So actually I am not interested, I'm just interested in doing the fluid flow simulation. So I will suppress this body, or even you can keep it also. I will maybe try to show with the help of both methods, one with the suppress and other which is not suppress. So this is the wall which is been generated, this is your fluid zone. So now I will move first of all I will save the work. So basically we'll categorize into 3 things. I will say Tesla wall. Okay, so Tesla wall simulation I will categorize into 3 cases when the outer wall is not considered. So let's say Tesla wall fluid simulation, only fluid zone. Okay, so again there are 2 directions, a forward and we can say reverse direction which is there. So I will say it is direction 1. Go inside, uh, copy and make it save. So there are 2 directions as well actually. So you can see in the paper also. Uh, so reverse flow and okay, you can see on the paper we'll see. So this is the 2 direction, forward and reverse direction. So we'll try to simulate it for the both cases, one for the forward and second for the reverse. So we have saved it. So this work is for the one of the direction. Now let's click on edit. So we'll generate the mesh now. So let's open the mesh window. Okay, so if you are finding such errors where okay, so that is generated, so not an issue. So let's click on generate mesh. So if the mesh size is not proper as per your requirement, you can go with some higher size of mesh. So I put it 0.005 and let's make it generate. Okay, so it shows error generate, not that fine. So let us set 0005. Let's make it generate. Okay, slightly on the finer side. So let's make it 0.00025. Maybe quite finer than the earlier one. So I take it 0.0001. So maybe quite finer than the earlier one. So the time requirement will be more if you are going with some finer size of mesh. So for 0.0025 it was quickly we have got the mesh, but in this case it is slightly taking more time. So definitely the accuracy of the result will be more if you go with a comparatively finer size of mesh. By chance, if your computer is not responding to the whatever the mesh has been generated, you can stop the process by clicking on the red button, or which was shown earlier. So now this is 6,74,000. This is the number of nodes and element. So what I will do, I will specify the inlet and outlet now. So this one I will specify as inlet. So this is one of the direction flow which I am considering. Similarly, I will show with the second direction flow also how it can be done. So create name selection. Let us say this is outlet. So what I will do, just click on update. You will see the mesh translation to fluent successful message. Once that message appears, you can proceed for the next part and you can close the mesh window. So I'm closing the mesh window. Now I'll proceed with the next part. So let's save the work and then we'll come back. Okay, so the next step is your setup. So click on edit. So select the number of processes you want to run. I take it 16, make it double precision. Even you don't require geometry here, so you can close the design modeler now. Just a minute, we'll just check one more thing in the geometry, whether we have specified the fluid zone or not. If it is not specified, then we might have to uh, open the mesh again if you are not done. You can actually define ladder also, but let's go to the design modeler and just check it whether we have specified the fluid zone or not. So if it is not specified, you have to specify it. So this is the fluid zone. Yeah, this one has to be specified as a fluid. So this is one of the thing which I miss. Okay, so what I will do, I will just close the fluent window once and we'll go back to the mesh. Go back to the mesh, say no, and I will just simply click on update option. Even you could have directly click on update, but I will preferably go here and click on update geometry from the source. Now this will be as per the fluid zone which we are having. So one more time I will generate the mesh, and one more time I will do the same operation, that is mesh translation to fluent successful, that I will require. So you may have to update this. So once that message appears, you can actually proceed for the next step. So again, as we took slightly the finer size of mesh, so definitely it will take some more time. Okay, so this is done. So click on update. You will see again the mesh translation to fluent successful. Now you can just close this window of mesh, and okay, so the fluid flow fluent, as we open it, just click on reset, and one more time click on clear generated data. So the mesh generation is done. You can now go to the setup part. So select the number of processes. I will select the double precision. I will put it 16. Click on start button. So now the next window that will appear. So here we have to proceed for the next step. So we have to wait till the object is loaded here. Once the object is loaded, you can proceed with the remaining things. The loaded object will show you the inlet and outlet in the form of the arrows. Okay, so object is visible. So click on show tiles. Then I will select gravity, put it minus 9.81. Then I will go to the materials. I'm not going to change any model here as of now. So go to the fluid database. I will select the fluid as a water liquid, make it copy, then close, then close. Cell zone condition, I will put the fluid as the here water liquid, make it apply, and then click on close. So boundary conditions, I will put inlet. So the boundary condition, I will put the velocity, let us say as 0.1 meter per second, make it apply, then close. Go to the reference values, select compute from, I will select it from inlet. The reference zone will take it fluid. Go to the initialization, go to the standard initialization, again tell the computer from where to start, then click on initialize. Calculation activities, so I just click on auto save option about 20. You can actually set the animation, but I am not setting the animation because it may take more time. So I just click on calculate. So once you click on calculate, so you will see uh, this residual and the iteration process started. If you set the animation, you can say you can actually visualize the path lines here itself, but ultimately we are going to visualize this in result and the calculation will complete quite earlier. So that's why I'm not setting any solution animation, but you can actually set the path lines, if you want to visualize how the fluid particles are moving from, let us say, inlet to outlet when the iterations are being performed. But preferably when your configuration of the computer is very good, in that case you can go, otherwise the system will become too much of slow and the time requirement will be more. So that's why I'm not setting it, but you can actually set it. So we'll wait till the time this calculation is complete. Once the calculations are completed, you will see a message that is calculation is complete. Then once the calculation complete message appears, you can actually proceed for the next step that is related to your result. So till that time we have to wait and uh, for the calculations to get complete. So you can see the calculation message, complete message appeared. So one more time I just click on save button, and now I can close this window once the saving is done. So I can now close this window and close fluent option. Now I'll proceed with the next step that is related to the result. So click on result and click on edit. Now here you will be in position to visualize uh, the simulation for whatever the iterations which we have performed. So accordingly we will be in position to visualize the simulation. So I will select the path line option here, a streamline option here. So I will select it from inlet. Let's select the number of particles, maybe let us say 100, and click on apply. So depending on uh, the configuration, it may take some time. So if you want this legend to be better visible, I will select left center. Appearance, instead of scientific, I will make it fix. The value tricks also I will increase. Size here also I will increase. Aspect ratio also I will change. And let's visualize it. So this is how it is visible. So I can make it uh, proper on the screen, and then accordingly I can visualize the simulation results. So now select the time sweep animation, streamline, make it slow, and let's click on okay. So one more thing is I will select the symbol size to slightly lower so as to visualize it in more better way. So you can see how the particles they are moving from inlet to outlet. So in this way, this is how the fluid flow simulation that can be visualized for the Tesla valve. You can actually go and uh, select the different symbol size also. Let's say I'm reducing it to further. Now you can see how the particles are moving. So in this way, this was based upon the direction which we have selected. So we can actually go with some other direction which we have specified here. So let's click on stop button. If you want to save the movie, we can click on save button, and accordingly you have various options to save like HD, 4K, and so you can select the custom and you can save it in the 4K mode also. So in this way, the simulation that can be visualized one more time, just to have a quick look of how it is there, how the particles are moving. So let's click on close button. Okay, so let's have a click on the save option here, and I will go to workbench window and click on save button also. Okay, so this is one of the direction which we have considered. Now we can go with the second direction also. So I will just, so we have run the simulation for a particular direction. Now I will change the direction. For this I will save this file uh, first, and then I will go with this. So click on this option. uh, the post processor I will close. So click on close CFD post. One more time, save it. Now I will do save as. So I click it save as. So earlier I was selected direction 1. So now I will select Tesla wall fluid simulation only, fluid zone direction 2. So now second I'm selecting is the direction 2. So copy address, click on here. So remove the things not required. So we are now proceeding for the second direction. So earlier we considered the inlet at one side, and now I will just change the inlet and outlet and we will visualize the simulation. So this is a very simple process. You don't need to invest much of the time. You can just open the mesh part and just change the inlet and outlet. So earlier if you see, this was your inlet and this was your outlet. So now I will just change this here. This one I will specify now as inlet, and other one I will specify as outlet. So this is the one face. I will make it, I will select the face here, so make it apply. So this is your inlet now. For outlet, now I will select this as a face and make it apply. And now you can see, earlier this was inlet and this was your outlet. Now this is inlet and this is your outlet. So make it update. So one more time we are making update. Mesh translation to Fluent successful. Close the meshing part. So you don't need to put the boundary conditions in this case. You just have to click on update project. You have to wait till the whole project is getting updated. Once the whole project gets updated, you click on result part and you can directly jump to visualize the simulation. So we'll just wait till the time this the processes get completed, and will. So you can see the process has been completed. So directly you can jump to the result part, click on edit. So the way it has been saved in the previous work, the same thing will be loaded as it is. You don't need to change anything. Only thing what will happen now is when you go to the sweep animation and when you run the simulation, you will see the direction has been reversed. Okay, earlier the direction was here to here. Now the direction has been reversed. So I just click on stop button and will change the size of the symbol. Let's say put it slightly on the lower value, and let's visualize it again. So this is how the direction which we have changed. So we don't have to change uh, so many parameter. We just have to go to the mesh. You have to click on the save button. Sorry, you have to go to the mesh and then you have to go to the name selection and change the inlet and outlet. So that is what you have to do. Once that is done, you have to click on update. So the mesh translation to Fluent will be successful, and then you have to come back to the workbench window and click on update project. So accordingly, the very less time will be required if you are doing such operations. Okay, so now this is the second case which I was interested in showing. I will just click on save project here also. so that the settings in the we can say post processor will remain the same. So click on CFD post, click on close, one more time click on save button. Okay, now the third case today we are going to see is uh, with some we can say, as you are as we remember, while preparing the geometry we have suppressed the solid part. So now what I will do, I will save as this work, and I will save with the different folder now again. So only we have considered fluid zone also in the earlier two examples. Now I will do, say, Tesla wall fluid simulation, fluid and solid zone. So this is what I am doing. So earlier I suppressed the solid portion, so now I will consider that portion also. Let's click on save. So now this will be the same file which will be saved with a different name. Only thing is I will go back to geometry, click on edit. Now in the geometry I will unsuppress the body which we have suppressed earlier. So this is the solid, so I will make it unsuppressed bodies. Now I will go back to the mesh again, make it no. So in mesh I will click on update geometry. So once the mesh is open, I will click on update geometry. So you will see geometry option. So I will click on update geometry. So okay, not an issue. So just click on generate mesh. Now the thing is, whatever the element size which we have selected earlier, so that element size may be very fine for this case, because we are also considering the solid part as well as the fluid part, and that's why. So you might have to reduce the element size whatever it was present earlier. Okay, I will just click on generate mesh. So this could be very fine whatever we have selected earlier. So we might have to go with some different size of mesh, or I just click on this stop button. So this was very fine for the object. So one more time I will just click on generate. No, sorry. I will click on generate mesh. So I change the element size here, because earlier only the fluid zone was here. Now along with the fluid zone we have the solid zone also. Okay, so some error is showing. So what I will do, I will just close this. I will click on clear generated data and close meshing. So if you are observing such errors, you can close the mesh. So what I will do, I will just clear generated data and reset here. So now you cannot do an update option here, because uh, what will happen, you have two different zones now. Earlier the zones was same, everything was as it is, so that's why you can directly click on update. But here, as the zones are separate, so you cannot just click on we can say update project. So I will just open the mesh again, and now the design modeler is not required. Okay, okay, so let's click on clear generated data. And then close this. So one more time. Okay, ensure that this is a fluid and this is a solid. So let's click on reset. I click on clear generated data and click on edit. So wait the geometry to be loaded. Okay, if it is not loaded again, so clear generated data and close it. Okay, so now click on edit. Now it will be visible. So if you are observing the same error, so this is how you can proceed. So just click on here. Now let's the mesh size which I want. Now I will first of all I will generate the default mesh. So this is generating default mesh which will be not be suitable. So 0.005 I will put first and then click on generate. So this is not that good. So 0.001 I will put, make it generate. You also need to take into consideration the statistics. You should not go beyond a particular value. So I will take it 0.0000005. Let's make it generate. We want better mesh, especially in this region wherever the fluid is flowing. So 43,172. So you might have to go with some finer size of mesh here. So definitely the time requirement will be more, but especially for the fluid zone, we required a good quality of mesh. Then only will be in position to visualize the result in proper manner. Okay, so this looks to be better, quite better, but it can be modified further. Let us say if I take it 0.00, sorry, 0002, make it slightly more finer than what it was earlier. So if you are having a better configuration, you can go with this finer size of the mesh. Otherwise, if you don't have, you can go back, continue with the earlier mesh size which you have selected. Okay, so this is looks to be quite better than what it was earlier. So again, there can be two directions again, just like we have done earlier. So here I will select, this is the create name selection. Here I will select inlet, and here I select as outlet. Okay, so we have inlet, outlet. In addition, you can actually specify this as wall and something like that. So it again not necessary. Even if you are not specified, still it is okay. So we'll see mesh translation to fluent successful. Once that message appears, you can close the mesh window and proceed for the next step. So this is what again I will do, reset, click on clear generated data here also. Now open the setup, select double precision, I put it 16, click on start button. So if depending on the models now, which model you are looking for, whether you are looking for cooling model or just we are interested in the fluid flow fluent, so accordingly the respective models can be selected. Here still I am going with the steady option, but if the temperatures are involved, you can go with the transient option also. So I'm going still with the gravity same, that is minus 9.81 here. So if you are involved with some temperature and other thing, you can put it to transient model. So this also model I will keep it as it is. Materials, I will add two different materials. So one is the water liquid available here. Second one, by default I will use the aluminum material. Cell zone, I will specify that you can say zone fluid. I will select the water liquid, make it apply, then close. Solid, by default the option will be aluminum, so I will not change anything. At inlet, put some velocities. So let us say the velocity I put it 0.1 meter per second, make it apply, close. Reference values, compute from, let us say, inlet, here fluid, then initialization, standard initialization, compute from inlet, click on initialize. So click on the tile button. So click on calculation activities, let's put it 20. So run calculation, I will just put it maybe 100 value, and we'll start the calculations. So again, after some time the calculation will complete. You will see the message which is calculation complete. So if especially the heat transfer problems are involved, as I said earlier, so in that case it will be very helpful to specify all this thing, because as a temperature or other, so let us say this is kind of model is involved where the heat is generated by the cells and which is to be dissipated, and we have some kind of cooling arrangement. In that case, this arrangement will be useful, whatever we are specifying. But we are in this situation, we are just consider a fluid flow model. You may select the transient, then K epsilon model, enhanced wall treatment, thermal effect. So this can be specified if the temperatures are also involved. So once the calculation complete message appears, you will close the Fluent window and we will move to the setup part. Sorry, we will move to the result part. So just like in previous case we have changed the direction, here also we can change the direction, and we go to the mesh, just change the faces where inlet and outlet was specified. You can reverse it, and then go to the click on update, and then go for the workbench window and click on update project. Okay, so this is message app here. You can close the Fluent. And last process is to go with the result part. Click on edit. So if you remember, we have clear generated data, we have done a reset option. So that's why the same window which was earlier may not be visible with the path lines. So you have to streamline. So you have to set the streamline again as what we did earlier. So make it apply. Then as I said, you have to legends also you have to specify left, center, whatever the, as we have done the clear generated data, that's why this settings was not visible as it is in the previous case. So put it in proper manner and let's visualize it. Click on sweep animation, streamline, slow. So this is how you can do. Same way you can change the you can say the direction, and accordingly you can visualize it coming from this direction to this. So the process is very simple. Again, I will show you this process. So close this, click on save button. Okay, click on save project. Go back to the workbench window, click on save. Now close the post processor. One more time save. Close the design modeler. So this is one of the case which we have. One more time we'll select. So now I will click as save as. So the fourth case will be Tesla wall fluid simulation, fluid and solid zone. So I will say direction 2. So make it copy and then V, control V. So click on save. So this will be saved as another file. So you have to go back to mesh again. Just click on edit and you have to just change the directions. So once the mesh is open, just change the directions wherever the inlet was specified earlier. So in name selection I will go. This was the inlet earlier. So I just click on face and now I'll specify this one, make it apply. So this is will be your inlet. Outlet I will select now this one, make it apply. So inlet is here and outlet is here. So click on update. You will see the mesh translation to fluent successful message appears. Once that message appears, you can close the meshing part. And now what you have to do is you have to go back to workbench window. Once this mesh window is closed, you have to go back to workbench window and you just have to click on update project. Once you click on update project, this progress, once it is completed, you can directly jump to the result part and you can visualize the result. So we'll wait till this process is complete. So this may take some time. So we'll wait. Completed. Now you can just click on result part, click on edit. So now everything will be loaded as it is. You just have to play the simulation in this case. So all the legends will be as it is what we have specified. So click on this, select sweep animations. So select the symbol size. Let us say 0.42, make it apply. And then, so you can see that now the direction has changed. Earlier was this one, now this is your direction. So accordingly you can do the various simulations. So whether it is the forward direction or whether it is the reverse direction. So accordingly the simulations can be done. So I will just click on save movie, click it here. Let's prepare a separate folder for this. So I prepared Tesla wall. So now we'll prepare a different folder here. Tesla wall, fluid and solid direction 2. So I just click on save here, and now okay, so which custom, I'll put it 3840 and then 2160. Then advanced settings, I will go with the higher resolution. So output directory I will say, so Tesla wall, so select, make it okay. uh, in addition, you want to specify this wall solid, you can put it here, and you can put transparency for this, say 0.9, make it apply like this. So in this way it can be visualized. So I just click on the play animation now. Okay, so okay, now wherever the file we are having in documents, so let's see Tesla wall where it is. So inside this simulation will be saved. So this will give you the path of each process. So this may take some time. So let's so these are the simulations that we can visualize. Now the fluid is moving from left to right. So this is inlet as a saturation and this is your outlet. So for this particular case, so the legend shows the velocity streamline. So this is the reverse direction which we are considering. So here is the inlet now and here is your outlet. Next, one more case with solid and fluid zone both. Fluid coming from inlet and going towards the other side. So again the velocity streamline on the as a legend. So this is again the velocity streamline, which is where when we are considering this one as an inlet and this is direction as outlet. So this is along with the solid zone which we have specified.